Welcome to Object-Oriented Programming in C++. Today our principal focus is on very important object-oriented programming paradigm ideas which are introduced in Unit 2, which are called mechanisms of object-oriented programming. So that we will see. And before that, a quick look at Unit 2 syllabus. Look at this. Unit 2 is completely devoted to objects and classes, it sounds new to you as you were doing programming only in C. And we have here classes, objects, access specifiers, constructors, destructors, copy constructors, assignment operator, front functions, front classes, structures and enumerations. Of course, structures were already introduced in C programming. You are aware of that. So to start with, we start like this. We give a sample program, we demonstrate you a sample program which looks like exactly a C program, and we will show how the paradigm change takes place. And that is the nectar of this crux of this object-oriented concept or mechanism that we will see right away, right here, right now. So don't worry about it. I'll take you seamlessly to OOPS paradigm. It's a little idea. Only made this much enormous revolution in object-oriented programming. As Einstein often says, little knowledge is very dangerous because so is powerful. When Newton was observing the apple was falling all the way towards Earth, he noticed that the velocity of the falling apple was continuously increasing. It was increasing with respect to time. So those days, even before 16th century or even late 16th century, Galileo also was arriving the speed time concept. In those days, probably you have studied in your schooling +2 and in 11th standard as well, that velocity, rate of change of velocity is what the acceleration. And this idea was actually conceived by Newton in late 16th century, and that result in mathematical differential calculus and integral calculus. If V is equal to velocity is equal to gravity 10, approximately 10, 9.8, 10 into t meter per second. If you differentiate V with respect to t, dv by dt equal to 10 meter per second square, and which is nothing but the acceleration. This is a small idea, very little idea, how much the mathematics has grown enormously, unexpectedly. Similarly, in trigonometry, the Pythagorean theorem, the cosines, if you take the fundamental idea as very little, but it grows later than more than a banyan tree, giant, it becomes giant. So many revolutions have been taking place in computer science and engineering, information technology, be it web technology, be it a compiler design, be it machine learning. It is enormously happening. In that case, this little idea of, I'll tell you, that's what we are moving towards, that has really made revolutions in programming style and programming paradigm. So to explain all this, to discuss all these classes, objects, access specifiers, constraints, and all these stuffs in your syllabus, we won't directly show you a PowerPoint and discuss them. Instead, we'll start from a specimen code, as I already told you. We'll go through that, we'll execute it, we'll see the output, we'll try to analyze the idea behind the program, and definitely you have to assimilate all this. Once you assimilate it, and after that you will be able to write appropriate code using object-oriented mechanisms. So let us move on to our first program, which exactly looks like C. At this juncture, I recall you the structures you have earlier used in C programming. Structures are, of course, user-defined data types, which actually informally structures are a group of basic data types under a single name. See here now on the screen, I have defined a structure named after student, which has three members: roll number, name, and CGPA. And unfortunately, I'm introducing a string data type here. Otherwise, we should use char array or character array, which become a bit complicated for us to read character by character. That is why it was introduced. The string object is already supported by C++. So no worries, it is direct only. The name is a string, it's a sequence of characters. Float is there for denoting CGPA, and roll number is a long type. So this is a structure. And as usual, we create variables for structure here. See here, we are creating variables for structure. Struct student S1, S2. You need not include this prefix, this structure creation with the struct as you do in C. C++ accepts without the keyword struct. Nothing wrong if you even add struct. So student S1, S2, you have created two variables S1 and S2. These two are variables of type student. And as usual, members of these variables you can access by simply putting a dot. Variable name followed by a dot, followed by, see here, the ID itself lists all these three members: CGPA, name, roll number. You put a dot here, then you see all this list. So S1 dot CGPA is equal to 9.1. This is legal, this is accepted. So the members of structures are referred by dot operator, or of course dot operator. Variable name followed by dot operator followed by member name. These conventions you know earlier. The same conventions followed here also. So nothing wrong with that. In addition to that, what I did was, I'm using two separate functions. See, look at this function prototype here. Read and process, these two functions I'm introducing of return type void. Process is a function. Read is also a function. Both functions are taking object reference as parameters, not just objects. You must pass objects as references. Only then, the object status is preserved. So for this particular function, read, void read, student, Ampersand object, I am simply reading values for these members. See, for this roll number, name, and CGPA, I am reading from keyboard. And that is what I have done here. C in roll number, name, CGPA. And before it asks, enter roll number, name, CGPA, you are entering it. That's it. Read function just performs reading values to this member data from input console keyboard. This process does a different thing. It takes object as parameter. It checks for CGPA's range. If it is greater or equal to 0, it prints got distinction. Otherwise, it prints or displays not get distinction. These are the two member functions. So in fact, you have a main function, which is the starting point of your program execution. Main is compulsory in C++, but in Java it is compulsory. Java it is compulsory, but the entire main comes inside an object. It is a complete object-oriented programming, Java, but C is not. So it behaves like, because it supports multi-paradigm, no? That's why. Main is there. So main function is there, where you create variables for these structures and use other variables also. I'm using a reference called sref. And apart from that, I have added two more functions. I've written two more functions, process and read. These two functions are really accessing, taking parameters of structured student, and they do some process on these objects. And now, see here, these two objects S1 and S2 I have created. I'm using only S1 here. You look at this. I'm using only S1 here. I'm defining a reference variable for S1 as we have done in our previous video, because we have to pass object as a reference to these functions. That's what. Let us see the output now. Let us execute it. Let's compile it. It asks for, see it, it asks for roll number. I'm entering 100, name, Raman, CGPA 9.2. See, Raman got distinction. This is what our output. Raman got distinction. How it came? How it came? Because here, see, I am invoking or calling read function. I am passing this S1 object reference here. So the value has been read and has been successfully stored. And after that, the same object is passed, and I'm invoking function process. This process, upon receiving the object, object reference, it just checks the value of CGPA. If it is greater than or equal to 9, it prints got distinction. Else it prints not get distinction. Simple. So it is simple program which demonstrates how an object can be passed as reference, as you've already seen. You got a question also. I think, if I remember, you got a question also in our end semester 2025 C programming examination, passing objects as parameters. 16-mark question it was. That's what. So two functions are here, except main. If you add except main also, including main, you have three functions: main function, process, and read. Three functions are here, and you have structure. Almost all these three functions, main, process, and read, all these three functions are using this data type student. I'm creating S1, S2 here. S2 is for just, I'm creating, I'm not using it anyway. You can even delete it if you don't need this. These two functions, read and process, these two functions are using this S1 structure. Fine, I got the output. Now, if you seriously look at this structure student, it has only data. Roll number is there, name is there, CGP is there. Now this structure members, roll number, name, and CGPA are accessed by process and read functions. This is very obvious. The idea now is to think, that's what I was talking about, the very little knowledge is very dangerous. The little knowledge here comes. See, why don't I cut this function? See, void read, I'm cutting it. I'm pasting it here. Inside this structure, what would happen? Similarly, void process, I'm cutting this function also, Control X, and I'm pasting here. Now see, main is isolated. Main is the only function. It's isolated. Here I have a structure called student, which has three member data: roll number, name, CGPA, and apart from that, now two more functions added within this structure: read and process. Why I am adding these two functions? Because these two functions are accessing this data. These two functions are not accessing any other data than these than these three member data. That is why I feel comfortable. I'm doing all the way. So now I have a structure with the two functions and the three member data. Do you agree? Yes. Now, will this program work? Definitely won't work because this is after all a structure. The structure do not allow functions to be a part of their member. That is why classes were introduced in C++. This is the nectar, this is the idea, this is the crux of object-oriented mechanism. This is the little knowledge. Now you got it? Member data and member functions are binded together, tied together into a structure called a class. Now you should have got the definition for a class. So now I'll remove this keyword struct. Instead, I'll add a class. Now it will work fine. But prior to that, we have to remove all these because I do not need any more function prototyping because these functions become part of structure. Let us do one thing. We will simply copy paste this original version so that we can save our time. Now let us run this. Yeah, it works. Wait for a moment. Let us rebuild it. That's working. Now you look at this code. What change we have made? Instead of structure, we add this keyword class. The same roll number, name, CGP is there. You forget this public. You forget the student and all these things. You forget all this. Void process is there. Void read is there. And these two member functions and these member data are put inside a structure called class. And how to access these member functions? The same way as you access the data. The same dot operator you can make use. You have to make use this arrow operator whenever pointers are taken into account. That is what we have did in C also. When you create structure pointers, how will you refer the member data? Hyphen greater than. Hyphen greater than. That is what we have done here. I'll tell you. We will discuss this. These are constructors. We will discuss this in a separate video because we have to go in detail about all this. You need not panic really. These are very fundamental. You can even delete this. If you don't want, you can even delete this. We will delete this. If it is really confusing you, we will delete this. No problem. Simple. Now let us build. Yeah, it's compiling. No problem. Absolutely no problem. Now these two member functions read and process are inside a class. So here the same way I am creating an object. Now it is not at all a variable, it is an object, because now student is not a structure, it is a class. When it comes to class, and if you create a class variable, we have different naming convention called object. So informally, object is variable of a class. Then what is a class? Class actually contains member data and member functions binded together. I can call otherwise class as a blueprint of an object. Therefore, at any given instant of time, a typical class contains member data and member functions. What those member functions are all about? These member functions are usually destined to access these member data. It is always a good practice to devise member functions which accesses those data within the class. That's important. Of course, you can overlook this convention when we discuss friend functions. If two objects functions are friend, two classes functions are friend, they can access each other's data. That's a different case. Of course, logically, it is a cardinal sin, I should say. It is a cardinal sin if one class member function accesses member of other class directly. But anyway, this facility is also introduced through from functions. Fine. It's very obvious. See here, I'm creating an object S1. S1 dot read. This member function read is invoked. Once it reads this, the data is stored here. Roll number, name, CGP, all stored in this object S1. Then processes simply. Now you need not pass any references, because why? These two functions are part of this class. These two functions, process and read, has full rights to access all these members. This class is a family, really. This class is a family having 3 member data and 2 member functions. So these member functions has always right to access these member data. No other function out of this class can have access this data, can have access to this data. This idea is called data hiding. Data hiding. So now you know what is data hiding. Now you know what is member function. You know what is a class. You know what is an object. A more formal definition for a typical object is an instance of a class, variable of a class. You can define several objects for a class, as you have done in the case of structures. I have created only 2 objects here. I can create one more object also. My obj. Definitely, it will also work fine. Also, you can create array of objects. Nothing wrong in that. You can create array of object. You can create object pointers. You can do wonders with this. Hope now you got the idea. Hereafter, when you are given an application, you are given an assignment to write program, you should think this way. Instead of writing just declaring data and keep on writing functions, you first think of a class. What are all the data required to solve the problem? You put it in a class. And what are the process involved? And what member functions should you add so that these member functions can access these data and bind them together inside a structure called class. You create an instance, create object, you invoke the functions. All is done. That's it. This is the fundamental idea. Now let us have a quick look at the slides. See, object-oriented programming features are different. C++ features are taking different dimensions, different definitions. You forget about it. This we have discussed. in our previous video. Now, when it comes to object-oriented mechanisms, these are all the mechanisms: classes, objects, encapsulation, abstraction, inheritance, polymorphism, and all these things. These are all these are often called. If you forget Bloom's taxonomy, almost you should not forget it really, because every word matters in Bloom's taxonomy. Mechanisms, features, and components are almost literally mean the same thing. So when you are asked, list the features of object-oriented programs, list the features of components, list the features of mechanisms, or write the mechanisms, the same answer comes like this. Classes, objects, and all those things. Now, in a nutshell, you define classes. Classes are blueprints of objects. Classes contains member data and member functions. Member functions are to access member data. Then objects are instance of classes or variables of classes. A single class is just a blueprint. It cannot be used really. You must create objects to execute the program. Encapsulation is nothing but binding data and functions together. That is what your class does. It is always assumed in such a way that those data present in a class are to be accessed by only those member functions which are declared inside of the class. Abstraction, actually, this idea comes before abstraction. Let us see. Let us again go back to the program. See here. I have defined public here. These functions are public functions, meaning that these functions can be accessed outside the object. Suppose if this public keyword is omitted, normally all these two functions becomes private, which are not visible outside the object. Now let us try to compile it. Definitely it will compile. No, it won't compile because see here. You always have a practice of looking at these error messages. Error messages are also like senior professors. They'll hint you where your bug is and what is your blunder and where is the glitch in the code and all this. So look at this. Number 38, line number 38, it says void student read is a private with this context. So private function. By default, remember, by default, if you not mention explicitly, C member functions are by default private. C member data are public, which means you can assign a value like this, s1 dot cgpa is equal to 9.9, like this you can assign. It is admitted. Let us make these two statements as comment, and now let us try to execute it, compile it. I'm rebuilding it. See here. Is it working? Oh, fine. Therefore, both member function and member data are private by default. In GCC compiler, both are private. So you have to make it public. You can make these member functions as public. Member data as public. Make it public. Then build it again. Rebuild it. Now it is compiling. Fine, it is compiling. You can run it. Definitely it won't generate any output because you are not calling any function. So fine. You can make this private. And you watch what happens now. You can save it. Control S. You can save it. Build it. What happens now? See? It is private in this context. Now, let me make it private. Even if the keyword private is not private, it is default private. So I'm making functions public. I'm making member functions as public and data as private. And this is the convention you must often follow. Your member data always should be. This is not a rule. This is not a rule. Your member function is always desirable to be. Your member data is always desirable to be private, and public member functions are usually desirable, advisable to have public member functions. Now see what happens. Let us recompile it. It's working fine. See, roll number, name, not distinction. Why Rajani not distinction? Because below the margin. Great. It's working fine. Vijay. 9 point, not 1, not 3, for example. Distinction Y is above the margin. That's right. Above or equal to margin 9.0. It's working fine. So these private and publics are access specifiers. The access specifiers actually endorses or confirms whether these data can be accessed outside the object, outside the class. Right? If the members are public, it can be accessed by using the object name followed by dot operator, otherwise they cannot be accessed. We will often have a lot of private member data and private member functions also. Then how these privates can be accessed? Yes, of course, you have at least one public member function. This public member function can in turn access those private data or private member function. That we will see when the example comes. And one more information for you, these member functions are called as methods in Java and in Python. These member data are often called as properties and methods. So when you say class or object in general context, you will say properties and methods. Properties are member data, methods are member functions. And sometimes mathematically people use it to say operations and data. What is operation? Operation is nothing but your member function. Operations and data. Now let us come back to the slide. See here. Abstraction hides complexity. One thing. Suppose I am having a private member function which is implementing some logic. Since it is private, it is not visible outside the object. So this idea is abstraction. This is not known to outside world or even to the programmer. This function, this private function may be accessed by some other public methods or public member functions. So this idea is of having, if sometimes you are asked, give me an example for abstraction. These are all high, these questions are seems to be high order thinking skills. Nothing high order, it is extremely lower order only. Understood? So if you ask an example, you just write a class with the private member function which implements a simple logic like finding simple interest, compound interest, all those things. And you have one more public member function which calculate interest. This calculate interest function, public function, calls private member function in turn. That we will see in the subsequent classes. Understood? So encapsulation is to, abstraction is hiding the complexity of a, hiding the complexity of a class, of course. Example is, you can have private members implemented inside the class. That is the example. Encapsulation, every class is encapsulated. You know what is capsule? Capsules, you might have consumed capsules when you went to hospitals. Capsules are actually modules containing some drugs inside. Encapsulate means it's a verb. Capsule is a noun. Encapsulate means it's a verb. You are putting something. You are wrapping up some medicine or drug with this container, like it's what we call capsule. So encapsulation means wrapping up something. WRAPPING, wrapping up. You're gift wrapping things, to a friend's birthday, your relative's birthday, gift wrapping things, and you are giving them, That's wrapping, binding together. So that is encapsulation. Inheritance, actually the idea is you have a class, you are using it. Suppose you want to implement some additional logics without modifying the existing class. What you should do? Instead of creating the entirely new class, which is again compromises reusability, because every time you cannot write the same code. That is not the purpose of reusability. That is not the purpose of object-orientedness. You create a new class called a derived class. We'll discuss in Unit 2. And still, you can enjoy the benefits of the existing class. You have a class which has some member data and member function. You create a new class. This new class can exploit, can make use, and the existing class's feature. And in the new class, you can add some additional logic. You can have additional member functions. That's very interesting. So definitely, inheritance promotes code reusability. Polymorphism is nothing. Polymorphism is a particular function. Suppose you have a function called calculate. Calculate is a function. Why to calculate? Open parenthesis, close parenthesis, you have a function body. Can you have one more function similar to this? Yes, you can have the same function. But how the compiler differentiates these two? Because the ambiguity comes. Either the second function with the same name, calculate interest, or whatever, can have same name, but now the second function can have a return type. First function may not have a return type. Both functions can have a return type, but different data return type. The first function can return integer, int calculate interest, open, close. Second one is float calculate interest, open, close. Otherwise, they can have different arguments, different argument numbers, different. Even if they have same set of two arguments, the type can be varying. It's nothing. It's very simple, and also we'll see an example in our next upcoming videos. Dynamic binding is already there in C also. You allocate memory during runtime. That is dynamic binding, because the compiler do not know. The compiler do not allocate memory, in fact, until the program is being run. Actually, your compilation process, when you run a program, it has three parts. Compiler translates to machine code, then linker that actually copy pastes all the library modules to your program. So now you got a complete program, and after that, one more important operating system service which lets you to run your program is called loader. It takes a program and has to store the program into main memory. It has to perform a lot of memory management services. These you will study when you study operating systems. So the loader takes care of this. During program runtime, it has to take care of, I'm sorry, I afraid loader won't take care of allocating and dynamic memory. Dynamic memory, your program itself takes care of. Again, you will be using a lot of system calls and all those things. It's a very complex process when you go get into lower level code. It's a very complex process. Not just your program is simply running. You understand that. You run a program, you compile a program, it converts it into object code, machine code. If your machine code is not running, your compiler inserts a lot of system calls. Your OS has to provide a lot of services to successfully run a program. It's very messy when you get into that. It's very interesting also. So that's dynamic binding. Message passing is communicating between objects. You may have different objects. We had seen objects like student here. You can have another object staff. These two staff can be staff code, staff department, staff designation. Assistant professor, professor, HOD, dean, director, like that. So these objects can communicate, can pass messages. Message passing is a very interesting idea. We are still using in so many web applications. When you go for server-side scripting, definitely you will learn all this message passing, where it is really used. APIs, application programmer interfaces. Because as we have seen, as we are discussing, every component is an object here when you go for a publication or wherever you go. So to make use that, there must be a mechanism to pass, transfer data from one application to another application. That is, after all, the idea of message passing, how objects are interacting. You have a lot of API endpoint objects when you use HTTP protocol. You have a lot of API endpoint objects at the server side. So now let us not complicate it, getting into all those. And that's what visa access specifiers, private, public visa, and protected. One more access specifiers are protected. When a class member, maybe a function or data, if it is protected, definitely it is exactly like private, except that these members are visible to derived classes. That is, during inheritance, your new class, say child class, may make use an existing previous class, can make use of facilities of inherit the facilities of existing class, called parent class. So when a parent class has members protected, then these members are visible to subsequent derived classes also, that we will see when we come to unit 3. And of course, destructors, constructors are nothing more than special member functions. These constructors are member functions only. These constructors are generally used to initialize member data. Similarly, destructors are special member function. They used to generally they used for housekeeping or like deallocating memory and all those things when an object is destroyed. When an object would destroy exactly when your program ends, the object is naturally destroyed. So prior to getting destroyed of an object, some housekeeping may have to, for example, closing files. Open files must be closed. Closing web sockets. If web sockets are not closed, what would happen? There may be, threat of intruders. Right. Constructors can be overloaded. constructors are special member functions. They do not have any return type, yet they take arguments. They can have default, parameters. There are three type of constructors. You will see all those next video in detail. Default constructor, parameterized constructor, copy constructor. These constructors discussion is, of course, cannot go more than 3 minutes. Definitely. That's it. And thank you for now. See you in the next video. Thank you.